Hello everyone, I am Divya along with my teammate Saket Reddy here to present our project poster. Our project is titled Cross-Domain Analysis for Detecting Human and AI Generated Text, with tools like ChatGPT becoming more common. It's getting harder to tell if something was written by a human or a machine. This creates problem in education, media, or online reviews where fake content can spread easily. Most current solutions detect AI generated text using English only benchmark datasets. But in real world content, which is more diverse with different languages and domains. So we set out to build models that could generalize better and detect machine written text even in new unseen settings. Moving on to the methodology and prior work, existing solutions usually focus only on English and benchmark datasets. So they often break down when applied to real world content, especially reviews or social media in other languages. We even tested our multilingual model on various languages it hadn't seen during training, like French, to stress its generalization ability. To address these gaps, we fine tuned Robota for English and XLM Robota for multilingual text using high quality labeled datasets. Then we evaluated them across domains and languages, including book reviews, Amazon reviews, and unseen multilingual samples to measure how well they held up in realistic use cases. So now let's talk about the architectures. For the monolingual system, we didn't just rely on a single model, but we started with a pre-trained robota detector that gives an initial prediction. Then we extracted additional features like writing style and sentence structures and passed them through two small MLP classifiers. These helped us refine the original prediction and reduce false positives. For multilingual system, we used the XLM Robota base model. We carefully fine-tuned it using optimized hyperparameters like learning rate and warm-up steps to keep training within our GPU time limits. We then tested it on unseen multilingual reviews to see how well it handled the new content. Both architectures were designed to balance accuracy and real-world usability. Now Saket will talk about the results and key takeaways.
So here's what we found from the results of both tasks. So in the monolingual setting, our model reached a high accuracy of 96.2% on the validation set and 62.4% of accuracy on the cross-domain test data, which is pretty strong given how different the test data was. And for the multilingual model, we saw 75% accuracy on validation and 53.1% of accuracy on the cross-domain test data, which is actually promising given the challenge of handling multiple languages with one model and the languages that the model hasn't trained on. And these results show that while models can perform well in familiar settings, generalization to new domains or languages remains as a challenge. Still, our monolingual system showed strong robustness, and our multilingual setup provides a solid foundation for future improvements. So, in a whole, what does this project taught us? First, AI detection is possible even across domains and languages, but it requires thoughtful model design and evaluation strategies. Second, relying only on benchmark accuracy is misleading. So, real world tests like cross domain evaluation are essential to know whether a model is truly ready. Overall, this project gives us practical view into what it takes to build scalable and robust detection systems in the age of generative AI. So, thank you all.